Our topic for today is engineering economy and the design process. A sound engineering economic analysis procedure incorporates the basic principles discussed in Lecture 1 and involves several steps. The definition of engineering economy study is accomplished using a structured procedure and mathematical modeling techniques. Economic results are then used in a decision situation that normally includes other engineering knowledge and input. The seven-step procedure is also used to assist decision-making within the engineering design process, which will be shown later. In this case, activities in the design process contribute information to related steps in the economic analysis procedure. The general relationship between the activities in the design process and the steps of the economic analysis procedure is indicated in the next table. This is table 1-1, which shows the general relationship between the engineering economic analysis procedure and the engineering design process. The engineering design process may be repeated in phases to accomplish a total design effort. For example, in the first phase, a full cycle of the process may be undertaken to select a conceptual or preliminary design alternative. Then in the second phase, the activities are repeated to develop the preferred detailed design based on the selected preliminary design. Here. The first step of the engineering economic analysis procedure is particularly important since it provides the basis for the rest of the analysis. A problem must be well understood and stated in an explicit form before the project team proceeds with the rest of the analysis. The term problem is used here generically. It includes all decision situations for which an engineering economic analysis is required. Now, recognition of the problem is normally stimulated by internal or external organizational needs or requirements. Now, once the problem is recognized, its formulation should be viewed from a systems perspective. That is, the boundary or extent of the situation needs to be carefully defined, thus establishing the elements of the problem and what constitutes its environment. The last is the evaluation of the problem. It includes refinements of needs and requirements, and information from the evaluation phase may change the original formulation of the problem. In fact, redefining the problem until a consensus is reached may be the most important part of the problem-solving process. Step 2 is development of alternatives. The two primary actions in step 2 of the procedure are first, searching for potential alternatives and screening them to select a smaller group of feasible alternatives for detailed analysis. The term feasible here means that each alternative selected for further analysis is judged based on preliminary evaluation to meet or exceed the requirements established for the situation. So it could either just meet or exceed, okay, equal or more than the requirements established for the situation. Searching for superior alternatives. Two characteristics here, which is creativity and resourcefulness, were emphasized as being absolutely essential to the development of potential alternatives. The difference between good alternatives and great alternatives depends largely on an individual's or group's problem-solving efficiency. Now let's talk about developing investment alternatives. Have you heard of it takes money to make money? So as the old saying goes, there are usually hundreds of opportunities for a company to make money. Engineers are at the very heart of creating value for a firm by turning innovative and creative ideas into new or re-engineered commercial products and services. Most of these ideas require investment of money, and only a few of all feasible ideas can be developed due to lack of time, knowledge, or resources. Step 3 is development of prospective outcomes. Step 3 of the engineering economic analysis procedure incorporates principles 2, 3, and 4 and uses the basic cash flow approach employed in engineering economy. A cash flow occurs when money is transferred from one organization or individual to another. Thus, cash flow represents the economic effects of an alternative in terms of money spent and received. Now consider the concept of an organization having only one window to its external environment through which all monetary transactions occur. Receipts of revenues and payments to suppliers, creditors, and employees. The key to developing the related cash flows for an alternative is estimating what would happen to the revenues and costs as seen at this window if the particular alternative were implemented. The net cash flow for an alternative is the difference between all cash inflows and cash outflows. When you say cash inflows, these are the receipts or savings, and cash outflows refers to the costs or expenses during each time period. In addition to economic aspects of decision making, non-monetary factors, attributes often play a significant role in the final recommendation. Examples of objectives other than profit maximization and cost minimization that can be important to an organization include the following: meeting or exceeding customer expectations. We have safety to employees and to the public, improving employee satisfaction, maintaining production flexibility to meet changing needs, meeting or exceeding all environmental requirements, and then achieving good public relations or being an exemplary member of the community. Step 4 is selection of the decision criterion. The selection of this decision criterion incorporates Principle 5, which is consider all relevant criteria. The decision maker will normally select the alternative that will best serve long-term interests of the owners of the organization. It is also true that the economic decision criterion should reflect a consistent and proper viewpoint. That's principle number 3, to be maintained throughout an engineering economy study. Step 5 is analysis and comparison of alternatives. Analysis and economic aspects of engineering problem is largely based on cash flow estimates for the feasible alternative selected for detailed study. A substantial effort is normally required to obtain reasonably accurate forecast of cash flows and other factors in view of, for example, inflationary or deflationary pressures, exchange rate movements, and regulatory legal mandates that often occur. Clearly, the consideration of the future uncertainties is an essential part of the engineering economy study. When cash flow and other required estimates are eventually determined, alternatives can be compared based on their differences as called for by Principle 2. Usually, these differences will be quantified in terms of a monetary unit such as dollars, or in our country, peso. Step 6, selection of the preferred alternative. When the first 5 steps of engineering economic analysis procedure have been done properly, the preferred alternative is simply a result of the total effort. The soundness of the technical economic modeling and analysis techniques dictates the quality of the results obtained and the recommended course of action. Now we're down to our final step. This final step implements Principle 7 and is accomplished during and after the time that the results achieved from the selected alternative are collected. Monitoring project performance during its operational phase improves the achievement of related goals and objectives and reduces the variability in desired results. Step 7 is also the follow-up step to a previous analysis, comparing actual results achieved with the previously estimated outcomes. The aim is to learn how to do better analysis and the feedback from post-implementation evaluation is important to the continuing improvement of operations in any organization. That's the end of our discussion for topic 1, lecture 2. Thank you.